Hi, my name is Monica Mobley. I'm the science specialist at the North Central Arkansas Education Service Cooperative, and today I am going to be walking you through a lesson that is covering two seventh grade physical science standards, and it is specifically a format that has been made so that it can be used digitally with students who are in a virtual learning environment, and also could be simultaneously carried out in the classroom. So one lesson, two purposes. I'm going to skip through a lot of the material in this particular lesson to keep it at about 5 minutes. So if you have any questions, please feel free to contact your science specialist at your local cooperative, or of course our cooperative. All of the science specialists statewide are available to assist you. So looking through the standards, we get to some student objectives. So these are the phases that students will be working through as they participate in the lesson and engage in the learning activities. The science practices, I included a slide for the students showing the practices. These really aren't just for teachers. It's important that we have explicit conversations with students about these practices and why they're important. Of course, these are college and career readiness standards. So these are things that whether you're going to the workforce or whether you're going to a 4-year or even 2-year institution, constructing explanations, designing solutions, arguing from evidence, those are all important skills. And of course, the cross-cutting concepts is how whatever we're learning relates to the broader body of scientific knowledge, but also just how the world works around us. And so that's kind of establishing upfront some relevance for students of the why do I need to learn this. And then we have a student-friendly lesson objective. This is a pre-assessment, so students would actually indicate what they already know about what is a chemical reaction, what's not a chemical reaction. This was built on a template, so students cannot change the actual face of the document. However, they can drag and drop the boxes into the categories in which they're appropriate. So that's giving me, the teacher, a way to actually see what they already know. And I want to see what kind of their reasoning is. So getting just a little deeper in the second part of the pre-assessment, I'm looking for a response about chemical changes. Now we're getting to our phenomenon. It has to do with rusting nails. So students would read the scenario and looking at whether the mass of nails increases, decreases, or stays the same. They are going to open a Jamboard. This does have to be made editable for students, so you need to go through and make sure that everyone is an editor when you change the sharing settings. And students are just going to say, do they think the mass of nails will increase, decrease, or stay the same when they're rusting? We're not really getting at the why at this point. And then the why comes here. They type their explanation. Why did they decide that it increases, decreases, or stays the same? To build on that idea, we watch a video from the Galvanizers Association that is showing that rust is accumulating on some nails, hopefully to get them start to thinking about that maybe something is forming on it that might influence their original prediction. So they go back to their prediction and they decide whether they want to change that or modify it in some way. Now we're getting into the actual investigation itself. So here I just used my iPhone to record a video burning steel wool. I took a small clip of that video and I stuck it on this slide. That is our big phenomenon that's going actually with the investigation. So they are going to see that steel wool burning, and they're going to just record observations about that, and then they're going to come down and see what questions they could ask about that. So what could potentially they investigate? This slide has tools that they would use for their investigation. If the students are present in your classroom, you can actually give them the materials and have them carry out the investigation, which I absolutely would recommend. But if there is reasons that they cannot share materials or social distancing, or they are in a virtual environment, then they can still interact with the materials on this slide. How would they use those materials to manipulate an investigation? What do they predict will happen when the steel wool is burned in terms of the variables? Watching a video now of me actually carrying out the experiment. They make notes of data that might be useful for later analysis. They go back to their original predictions and see what actually occurred relative to their prediction. And now they're revisiting that phenomenon. So the ignition of steel wool with a 9-volt battery, we're stating that that's a chemical reaction. And they're going to take that phenomenon and they're going to look at the evidence that they've collected. What do they think caused the phenomenon? So what causes the fact that the mass of the steel wool increases, and what evidence do they have that supports that thinking? We're going to take it a little further and have them develop a model of that burning steel wool system. So where did the increase in the mass come from? And then they're going to do some reading. So we have 3 nonfiction articles that they are going to use to collect some further evidence to support their explanations. Just for fun, we're going to let them look at the chemical reaction to see how they can make it bigger and more dramatic. There's a Jamboard so they can see what ideas they have. Obviously, increasing the surface area of the steel wool by teasing it apart would make the fire bigger and much more dramatic. And then they're going to go back to their initial model. And we want them to revise that. So if they want to add to their model, they could copy and paste their original model onto this slide and then add to it, or they can start from scratch. They could actually draw the model on paper and take a picture of it and upload it onto this slide. So I'm a big fan of actually doing some of the dirty work on paper. We get to a choice board, and so, oh, and I skipped that, the evidence from the readings is what is supporting the revision of their model. So now they have more information to add to that. Choice board here, 3 experiments that they can safely do at home without safety goggles. The 4th option is choosing their own adventure, so giving them an idea of what they, letting the teacher know what they plan to do to see if it's actually something that would be appropriate for them to carry out at home by themselves. And then they're going to just describe their experiment. They're going to include a system model showing their experiment. How did things change? Where did mass come in or out? Where did potentially energy come in and out? What changes did they see? To get them away from their computers, give them something else to do, they're going to go outside. They're going to identify 10 chemical reactions that occur in the world around them. What evidence do they have? So how do they know it's a chemical reaction? And then finally, they will choose one of those, and they are going to describe how or explain how the law of conservation of mass was upheld within that system. To finalize the lesson, we go back to the initial phenomenon of the rusting nails. The students have access to a new Jamboard, so they're going to talk about what they predict now or what they think would happen to the mass of the nails, and they're going to explain that. And at this point, what we're looking for is the idea that students actually realize that the mass of the nails should increase because there was actually a substance that was formed involving oxygen from the environment or from the system that was deposited on the nails, and that's how we're going to kind of measure it. So this could be kind of a final exit ticket sort of activity. One thing that I did not mention, this particular activity, this could be used as your summative assessment. If they can identify a chemical reaction and they can explain how the law of conservation of mass is upheld within that reaction system, and there's enough reasoning there that you can tell what they mean, then they have achieved the goals of the lesson. Okay, I hope that's helpful. Let your Arkansas Science Specialist know if you need any assistance with this. I hope you enjoy the lesson. I hope your students do too. Thank you.